Alright, this is your homework help for Unit 11, Lesson 1 for Math 2. And I'm just going to kind of run through a few of these problems here from today's lesson. I'm starting a little bit behind, so you may have already done a few of these. That's okay. First of all, the first part says find the degree of each monomial. What it's asking you to do here when it's talking about the degree is it's asking for the sum of the exponents is what it's asking you to actually tell them. So on the first one, for example, I have a 3 and I have a 3. So the sum of those exponents is 6 in that case there. For the next one, I have an exponent of n basically to the first power, so the sum of those exponents is 1. Over here, I have x to the first, y to the first, so the sum of those exponents is 2. In this case, there are no exponents, so my degree is 0. In this case, I have one variable, k to the fifth power, so the sum is going to be 5. And d is going to be to the first power, so it's going to be 1. Alright, the next part here, I'm going to go down and I want to simplify some things here. To simplify what it's looking at, and you'll see later on in future lessons, they're already being nice to you in a sense because they're saying that I have m to the first power and n to the fourth power, which matches this m to the first power, n to the fourth power. Those are essentially the same type of variables and the same kind of grouping. Because those groupings are the same, then I know that from my response, I'm going to still have m to the first, n to the fourth. That stays the same, okay? And what's going to change are going to be my leading coefficients here. And I'm going to go with a sign, which is plus. So 3 plus 6 is 9. And the back part of the variables remains the same. It remains the same when I add and subtract. It will change later on when I start to do multiplication or division. So for now, because we're adding and subtracting, that stays the same, and all I'm changing are the leading coefficients by doing whatever the sign tells me to do. The same is true for number 8. I can see that they are both a g squared, so my response is going to have a g squared in it, and I do 12 minus 7 for 5. Again, the same idea here. I have c to the fourth d, c to the fourth d, so I'm still going to have c to the fourth d in my response, and a negative 11 with a positive 12 leaves me with a positive 1. I could write it as 1 c to the fourth d, or just leave it as c to the fourth d. And then over here, again, I have z to the third, so that stays like it is, and 42 minus 15 gives me 12 minus 5 is 7, 3 minus 1 is 2, gives me 27 z to the third. Okay, and that's where we are there. Okay, on the next section, it's asking you two questions. It wants you to name the polynomial based, excuse me, it's that time of year. First, I want you to put it in standard form. That's the first step, and then name it based upon the degree and the number of terms. Standard form means I'm going to change the order around to be something like a squared plus a plus a number. And essentially I look at the exponents and I go down in decreasing order. So it's a to the second, a to the first, and then no variable there. So to rewrite this one, I'm going to put the negative a squared in the front. Then I'll write plus 7a, and then plus 4 for there. So that's the standard form. Now at this point I have to decide what is the degree and what is the number. The degree is determined by the first term, or the highest term you have there, and then the number of terms is how many we have. In this case I have 3 terms. So for the degrees, a couple notes to put here is I could have something to the 0 degree, like the number up above when I had 7 and I said the degree was 0. I could have it to the first power, second, third, and in our case the fourth as well. So when it comes to the degree, our choices are going to be, it's going to either be a constant, like the number 7 is a constant. If it's to the first power, that is going to be linear. If it's to the second power, we call that quadratic. To the third power is cubic, and the fourth power we just call the fourth degree. Okay? When it comes to the number of terms, if there's one term, we call that monomial. 2 terms is binomial, and 3 terms is trinomial. So when I look at number 11, I can see that it's the second power, which makes it a quadratic, and there's 3 of them, trinomial. Quadratic trinomial is what I have there. Okay, so that's what I do for that one. On the next one, there's no switching around anything. I just have the 2 terms. They're in order. I have the second power, first power, so it's okay there. Because of the second power, it's going to be a quadratic again, and this is a binomial in this case. Over here, it's to the 4th power. There's nothing to change. It's already in standard form. So I would call this a 4th degree monomial because there's only 1 term. This last one, though, I do have 2x to the 3rd. I can see that I have a plus 2x and a minus 4x, which combine to form a negative 2x. And I also have a negative 9 and a positive 8. So those two combine to give me a negative 1. This point here, I have a cubic, because it's the 3rd power, and there are 3 terms, so it's a cubic trinomial. Okay. Number 15. It wants you to find out what's the total number of pounds that were ordered. They did mozzarella, they did cheddar, so essentially it's asking me to combine these things. To combine those, I'm going to combine my like terms. So I have a p to the 3rd. I'm going to combine those together. I'm going to combine my p squared together. I'll combine my regular p's, and I'll combine my whole numbers as such. When I combine those together, I end up with 3p to the 3rd plus 6.5p squared plus 32p plus 200. And that becomes what I have. It's not asking you what this is, but this is, again, a cubic, because the cubic there, and we have 4 terms, so I don't know if that would be a quadnomial. I have no idea. We don't have those, so that's probably why it's not asking you to name it. But we do have 4 terms there. Flipping over to the back side, same type of idea. We're now adding and subtracting polynomials here. Let's just run through a few of these together real quick. So they're just stacking it up for you to help you see how to solve them. So we have 3r plus 7r makes 10r, and 5 plus 3 makes a positive 8. That's all it's asking you to do there. When I look at one that's not stacked up here, I could rewrite this if I wanted to. This becomes t to the 4th minus 4t squared plus 9. I have a plus with a minus t to the 3rd, which means it's really going to be a minus t to the 3rd, and then a plus with a plus stays a positive, plus 3t. So now I need to combine my like terms, or put things in the right order at least, to make it in standard form. And so I have t to the 4th, there's that one. I have a t to the 3rd, so negative t to the 3rd, got it. I have a negative 4t squared, got it. I have just a positive 3t, and then I have a 9. So a very long answer there, but that's how that one's going to work out. Let's give another sample here. I have one that's stacked. I have 4z plus 7 and a minus 6z plus a 1. This negative sign has to essentially be distributed to each part within the parentheses. So if I was to get rid of the parentheses, I have a minus 6z, and then this becomes a negative 1. Okay? So I'm changing the signs around because it's negative. It's like multiplying everything by a negative 1. So 4z minus 6z is a negative 2z, and 7 minus 1 is 6 in that case there. Okay? So there's a couple examples there. We want to do the same thing down over here, number 20. Same idea. Again, because I'm subtracting, all of these signs are going to change. So this becomes a positive 5k to the 3rd. This becomes a negative 3k squared, and this becomes a positive 8k. So now when I combine my terms here, I can get rid of that because I already distributed that negative sign through. I have a negative 6 and a positive 5. That leaves me with a negative 1k to the 3rd. I have a negative k squared. There's no other squared, so that's just by itself, negative 3k squared. So I got that one out of the way, got that one and that one. And then I have an 8k and a 3k, which give me a total of 11k for that one there. Okay, so good questions on that one here. When I look at the next kind of word problems here, I'm going to go a couple of these with you. This says how many more own than rent, which means I'm doing a comparison. When it tells me how many more something than something, more of something than something else, that tells me I'm going to be doing a subtraction problem because I'm comparing two things. As a result of doing a subtraction problem, that means I'm going to subtract all of this stuff. So I'm going to subtract a negative 6p, I'm going to subtract a negative 125, and subtract a 5286 from those things. So when I stack them up and subtract, I'm not adding them all, I'm subtracting the whole thing. Okay? So when I do that, what I end up with is a 4p squared minus 6p squared is a negative 2p squared. 360 minus 125 gives me with a negative 235p, and then 22,000 minus 5,000 something or other leaves me with 16,892. Alright, so that's what I have for number 22. On number 23, it's a great problem, and you will see things similar to this on your upcoming test, which is a long time from now, but it's coming up. It says the wallpaper border that runs all the way around the room is that long. So the border that goes around the whole room, right, is going to be all that. Three sides of the room have the following lengths. One length is 6f, another length is 5f minus 7, and another length is 2f squared plus 2. Okay, so it gave me three terms here to already work with. I don't know what that other side is going to be. But what I do know is I do know the total length is right there. Here's how I set this one up. Okay, I set it up like this. I said, well, let's just take the things that I have. I know I have a 6f plus a 5f minus 7 plus a 2f squared plus 2. Okay, and all those things there plus something I don't know, I'm going to call it a box, is going to be equal to 5f squared plus 19f plus 11. Okay, so let me write this in the standard form real quick. So I'm going to slide the 2f squared over here. So I have 2f squared, there's that guy. I have 6f and 5f, which combine to make 11f, and a negative 7 plus 2 give me a negative 5. Now I'm going to add to that something that I don't know yet, the missing side, and make it equal to 5f squared plus 19f plus 11. So what I'm trying to figure out is, what do I need to add to each of these terms to get over here? That's kind of the idea. Okay, so I have a 2f squared here, and it needs to become 5f squared. The difference between 2 and 5 is 3f squared. I have 11 here, and it needs to get up to 19. So 11 to 19, the difference there is 8f. And here I have a negative 5, and I need to go from negative 5 all the way up to positive 11. That's a little bit weird thinking, but if I have a number line, and here's 0, and I'm over here at negative 5, and I have to go all the way to 11, it's asking me how far is it to go from negative 5 to 11, which means it's 11 plus 5, which gives me 16. Okay, so 3f squared plus 8f plus 16 is the missing side length for number 23. All right, and we'll stop there for the day. Hope that helps you out with today's homework.